yeah.
4 major earthquakes, 3 countries, 8 hours. On a single Wednesday in June 2026, the ground shook in Venezuela, Japan, and California within the same 8-hour window. Venezuela was hit by 2 back-to-back earthquakes within 39 seconds of each other. Japan recorded a magnitude 7.4 that triggered a tsunami warning across hundreds of kilometers of coastline. California scientists published a landmark study warning that the San Andreas fault has reached its highest stress level in over 1,000 years. And the Philippines, Papua New Guinea, and Nicaragua were all struck in the same week. This is not coincidence. This is not unusual geological activity. This is what living on an active planet looks like. And today we are going to break down exactly what happened, why the outcomes were so dramatically different, and what the science is telling us about where the real danger lies right now. Subscribe and turn on notifications before we go further, because this situation is still developing, and the next update could come at any moment. Let us start with Venezuela, because what happened there on June 24th, 2026, was not just a natural disaster, it was a collision between geology and decades of human decisions, and the geology won catastrophically. At 6:04 in the evening local time, a magnitude 7.2 earthquake struck approximately 160 kilometers west of Caracas. 39 seconds later, before most people had even processed what was happening, a magnitude 7.5 struck almost the same location. 2 major seismic events in under a minute. Both were shallow, approximately 10 kilometers deep, which means almost none of the energy was absorbed by the rock between the rupture and the surface. Every joule of that release hit the buildings above with full, unfiltered force. Some geophysicists, using detailed source analysis, have suggested the combined event is better described as a single complex rupture approaching magnitude 7.8. On the logarithmic magnitude scale, the difference between 7.5 and 7.8 is not small. A 7.8 releases approximately 2.8 times more energy than a 7.5. Nearly 3 times more energy tearing through the ground for the better part of 2 uninterrupted minutes. In La Guaira, the coastal state directly above the rupture zone, reports indicate that approximately 80% of buildings collapsed. The capital, Caracas, experienced 60 full seconds of violent shaking, sending millions of people running into streets filled with falling concrete and debris. The international airport sustained damage and was closed. Power networks failed across large areas.
Yeah.
Mobile phone infrastructure collapsed at the exact moment it was most needed, preventing families from reaching each other and preventing rescue services from coordinating. The USGS issued an immediate assessment, placing a 44% probability on a final death toll between 10,000 and 100,000 people, and a 30% probability of more than 100,000 deaths. As of today, the confirmed toll has climbed to nearly 3,900 people. More than 16,700 have been reported injured. But every expert monitoring this situation says those confirmed numbers are a severe undercount. The United Nations Undersecretary General for Humanitarian Affairs stated publicly that more than 50,000 people remain missing. A forensic pathologist working inside La Guaira told CNN that the official figures represent, in her words, not even a third of what is actually there. The makeshift morgue at her facility was processing approximately 400 bodies per day. Refrigerated trucks were full. Body bags were being placed outside in the June heat because there was no space remaining inside. NASA satellite imagery of the affected region suggested that not the 700 buildings the government initially acknowledged as damaged or destroyed, but closer to 59,000 structures, including hospitals and schools, were actually destroyed or severely compromised. The United Nations placed economic damage between $4.7 and $8.7 billion. Other UN estimates placed total losses, including infrastructure, at approximately $37 billion. Roughly 6% of Venezuela's entire GDP erased in under a minute. Venezuela was already in crisis before the earthquake struck. Nearly 8 million people were already in need of humanitarian assistance. Hospitals were already under enormous strain, with minimal medical supplies. Construction standards in the densest neighborhoods had not been enforced in years. Infrastructure maintenance had been deferred indefinitely. When the ground lurched twice in 39 seconds, the buildings above it did not flex, they fell. Now let us talk about Japan, because what happened there in the same period teaches us something fundamental that no other country on Earth demonstrates as clearly. A magnitude 7.4 earthquake struck off the Sanriku coast of northeastern Japan. Ground shaking was felt from Hokkaido in the north to Aichi Prefecture in central Japan. Tens of millions of people experiencing the earthquake simultaneously. A 3-meter tsunami warning was issued for coastal prefectures. Approximately 44,000 people in Hokkaido alone received evacuation orders. Coastal residents moved to higher ground. An 80-centimeter tsunami wave was observed at Kuji Port. Final confirmed damage: roughly 200 power outages, 2 people injured from falls during the shaking, 0 deaths, 0 collapsed buildings. Read that again. Magnitude 7.4. Tsunami warning. 7 minutes of shaking felt across a nation of 125 million people. 2 injuries. Nobody killed. The contrast with Venezuela is not about the earthquakes being different. A 7.4 in Japan versus a 7.5 in Venezuela. Almost identical geological events. The difference is entirely what human beings built and prepared in the decades before the ground started moving. Japan operates under some of the strictest seismic building codes on the planet, updated continuously as new research comes in. Buildings are specifically engineered to sway and absorb energy rather than collapse. Train systems automatically stop when seismic sensors detect unusual ground movement. Hospital systems are designed to remain operational through major earthquakes. And from elementary school onwards, Japanese children drill earthquake response until it becomes physical memory. Japan also issued what is called a megaquake advisory following this event, a formal government communication stating that the short-term probability of a magnitude 8 or stronger earthquake has temporarily increased above baseline levels. The weekly probability rose to 1% compared to a normal background rate of 0.1%, 10 times higher than normal. Not a prediction, a precaution that the population is trained to take seriously. In this, Japan has proved something important to the rest of the world. The death toll from an earthquake is not determined by geology. It is determined by decisions made by governments and societies in the years and decades before the ground shakes. Now let us talk about California, because what scientists published in June 2026 about the San Andreas fault is one of the most significant findings in recent earthquake science. A research team led by scientists at the University of Bern published findings in the Journal of Geophysical Research showing that the San Andreas fault system in Southern California has now reached its highest stress level in the past 1,000 years. Here is what that means. Fault systems store energy. 2 tectonic plates grind against each other, locked by friction at the surface, while continuing to move at depth. That motion gets converted into elastic stress in the surrounding rock, essentially compressing and bending the crust over years, decades, sometimes centuries. When the accumulated stress finally exceeds the strength of the locked rocks, the fault slips. All of that stored energy releases at once as an earthquake. The southern San Andreas last ruptured in a major event in 1857, the Fort Tejon earthquake, estimated at magnitude 7.9. That was 169 years ago. For 169 consecutive years, the Pacific Plate and the North American Plate have been grinding against each other at approximately 5 centimeters per year without a major release. All of that motion has been converting into stress in the rock. The research team built a physics-based computer model simulating 1,000 years of earthquake history along both the San Andreas and the adjacent San Jacinto fault systems. Their conclusion: stress on multiple fault segments is now at or above the highest values observed anywhere in the entire 1,000-year simulation. The system has not just approached a critical threshold. According to the model, it has already passed it. The study also identified a second finding that makes the situation considerably more dangerous. the San Andreas and San Jacinto fault systems meet at a geographic junction in Southern California, known as Cajon Pass, approximately 80 kilometers northeast of downtown Los Angeles. The researchers found that this junction can function as what they are calling an earthquake gate. Under current stress conditions, a rupture beginning on one fault system can travel through Cajon Pass and jump onto the other, turning what would have been a single fault earthquake into a simultaneous multi-fault rupture. A joint rupture crossing Cajon Pass, according to the study, could produce an earthquake of between magnitude 7.4 and 7.8, threatening the Los Angeles Basin, San Bernardino, Riverside County, and the Coachella Valley simultaneously. With stress levels on both fault systems running at historic highs, the gate is effectively unlocked. USC seismologist Ahmed El-Gamal, when asked when the next major event might occur, said it directly. It could be today, tomorrow, in 10 years, or in 30 years. On geological timescales, there is no meaningful difference between those options. The consequences of a magnitude 7.5 to 7.8 event striking this corridor would be severe. Los Angeles has over 13 million people in its metropolitan area. Thousands of older soft-story apartment buildings constructed in the 1960s and 1970s are known to be highly vulnerable to this type of shaking. Gas mains, water pipes, and electrical networks all cross active fault traces. A major rupture would likely trigger widespread fires from broken gas lines, with water main failures hampering firefighting efforts, severed transportation routes including major freeways and rail lines, and hospital systems overwhelmed at exactly the moment they are most needed. California is not Venezuela. The state has Shake Alert, an earthquake early warning system now operational statewide that can provide seconds to tens of seconds of warning before destructive shaking arrives. Building codes for new construction are strong, but retrofitting older vulnerable buildings has been slow, and the gap between what scientists know about this risk and what the public understands remains large. Now, the question that this combination of events inevitably raises is something different happening right now? Is the planet more active than normal? The honest scientific answer is no. Earth experiences thousands of earthquakes every day. Magnitude 6 and above happens roughly 120 to 140 times per year.
Oh, Dios mío, ¿no quiere parar esto?
Approximately 1 every 3 days somewhere on Earth. When multiple significant earthquakes occur in the same week, that is statistically expected, not anomalous. Venezuela's earthquake and Japan's earthquake are geologically independent. Venezuela sits along the boundary between the South American plate and the Caribbean plate, a transform fault running east-west across the northern edge of the continent. Japan sits at the subduction zone where the Pacific plate dives beneath adjacent plates along the Japan Trench. These systems share no geological connection. The Venezuela earthquakes did not cause the Japan earthquake. What the recent cluster of activity does reflect is something simpler and more important. The Pacific Ring of Fire, a 40,000-kilometer arc of tectonic plate boundaries encircling the Pacific Ocean, accounts for roughly 90% of the world's earthquakes. It never stops. Japan, the Philippines, Papua New Guinea, California, and Nicaragua all sit along or near this arc. When you monitor global seismic activity over any given week, you will almost always see multiple significant events in this region. What has changed is not the geology. What has changed is the number of humans living in its path, and how many of those humans are living in structures that cannot handle what the geology will inevitably deliver. This is the central issue. The global urban population has exploded over the last 70 years. A massive portion of that growth has concentrated in cities near active fault zones. Tokyo, Jakarta, Manila, Los Angeles, Istanbul, Mexico City, Lima. All megacities, all within reach of major seismic events. The question geologists are most concerned with is not whether these places will be struck. They will be. The question is what state their buildings and infrastructure will be in when it happens. Venezuela showed what happens when poverty, political instability, and inadequate infrastructure meet a magnitude 7.5 earthquake. Japan showed what happens when a society takes geological reality seriously over generations and prepares accordingly. California is the most closely watched open question, and the most recent science is saying that Southern California's fault systems are sitting at stress levels not seen in a millennium. The death toll of an earthquake is a geological event combined with a human decision. That decision is being made right now in every city that sits near an active fault, by every government that chooses whether to fund retrofitting programs, enforce building codes, and prepare its population. The ground will move again. The only variable is what we have built above it. Subscribe and turn on notifications, because the next update on any of these fault systems could come before this video is finished loading on someone else's screen.